Yo, YouTube! How is everybody doing? So, um, I'm doing a myriad of stuff online here for you guys. My name is Greg. I'm from GregsTutoringNYC at gmail.com. You can see my email path down there. I'm a private tutor. I tutor one-on-one. I tutor in groups as well if you need that to be the scenario. This is part 4 of a series dealing with the greatest common factor. I put 8 series. Some places call it the highest, greatest common factor, and the least common denominator. There's a couple other names for this. So I showed you a couple of techniques to do this process so far. One was just by listing out factors, factor pairs. It's lagging. Yeah, you know what? It brought up my other YouTube for some reason. So I don't know how to get it in sync. Is my voice in sync with it? At least to start it up. Well, we're going to have to deal with it. I don't know any other way to do it except for ending this completely and coming back in, which may make sense to do. I'm not sure. Is it lagging that much? You're not answering me. So either you abandon ship or okay. In any event, so I showed you how to use factor pairs, how to use multiples, how to do prime factorization, and then we did kind of some sort of table mechanism. I don't even know what that's called, where we did some divisions, and this way created the L, made the LCD, and this part here was the GCF. So it turns out, given the way numbers are set up, this is true of a lot of things. For instance, I mentioned to you guys the other day that the distributive property like this is the same as A plus 0 times B plus C. So it turns out there's lots of mathematical identities and things like that that we don't normally, they're not normally obvious to us. And it turns out this kind of sub ideas, some sub theorems, sub formulas, just sub other ways to do other things. It turns out there's a couple of techniques here involving GCF and LCM that can cut down time of solving it. Now, the other side of the coin is every question on your standardized test is not going to be an LCM or GCF problem. However, what I think I'm going to do is going to do a bunch of different ones of these pertaining to practicalities involving math strategy. Oh, it's good now? Okay. Practicalities involving math strategy, where I'll show you ways to save time. And what's good about it is it saves time. It's just as good as any other technique. And if you can do it accurately, efficiently, and fastly and quickly, why not? Okay? So with that in mind, that's what we're going to do here. And there's a few things I'm going to figure out, because I'm not going to shoot for the college level kids here. I'm really shooting for later middle school, early high school kind of kids. There's enough proficiency that you've had in math that you should know how to do certain things. For instance, it could be adding numbers up. For instance, if I have 1 plus 6 plus 4 plus 3, you don't add this up from left to right. This leaps out to you, that's 10, and then you get 14. And this is how you should be adding numbers at this point, not necessarily left to right or right to left. And in fact, I've mentioned double checking things on your answers that way, but there's also better mathematical ways to do this, and it's going to be accuracy. And if you orient your brain, first of all, in enough people, I always never had this problem because it was kind of innate to me. But you can train yourself to think these ways, and it's just like nobody was born knowing what 2 plus 3 means. You're not born knowing what a plus sign means or 2 to the third. You're not born knowing these things, so you have to be told them. And you have to be informed the semantics, right? This is the syntax, is how it looks. The semantics is what it means and how it operates and how we can use it. So we need to be taught all those different aspects of it, all right? We're born knowing how to breathe and other things like that. Hey, it's my buddy Amy again. We're taught how to breathe, and we know how to eat and all this other stuff. Poop, all these are skills that kind of come with the territory of being an animal. But there's other stuff, a lot of stuff we have to be taught to do, including sometimes breathing. Like we're sitting here breathing right now, but you're not going to tell me that a swimmer, if you're ready to swim or run a marathon, that you're going to breathe the same way you and I are breathing right now, both before the race, during the race, and after the race. So we want to do that same kind of notions, abstractly and so on. Okay, well, I hope so. I enjoy what I'm doing, and the more the merrier. I'm not doing private YouTubes here. So the name of that's part of what YouTube is about, was spreading knowledge, dropping info, right? And I love it, I enjoy it, and I want to try to communicate that same love of learning and stuff to you guys as well. So if it catches on, it catches on. Why don't we jump into this HCF stuff, because I'm just pontificating a lot of words here. So let me go. I have a whole bunch of examples on a bunch of pages here. And my fan is going to end up blowing them at some point. So let me see what we have here. That's page 8. That's page 9. All right, so we're going to start with GCF first. So again, normally you might be processing these things and taking a minute or two to do it. So my goal here is not to tell you something like, you're going to do this in 1 second, because that's kind of being semi-fraudulent. First of all, for enough of you, you're going to have to do a lot of these problems and learn this. It's not necessarily something I need. And there's a whole bunch of steps to both the LCM and the GCF part here. But once you do the practice, it'll become instinctual. Just like my example before, like doing 2 plus 3 and 3 squared. Once you know what it's about and you've done 5 or 6 examples, it'll just be with you for the rest of your life. Or it should be. So what you want to do is kind of revisit maybe this YouTube and do a few examples once every 2 weeks or something. So again, I just did the thing, we have 80 days, so there's about 10 weeks, just 12 weeks or whatever until the SHSAT at least. And if you look at some of these things once a week or whatever, they stick with you. And then if you don't do it for a year, if you do it again in a year, it'll come back almost immediately, all right? But you want to start training yourself for whatever test you're going to end up taking so that you can do these things. And if we consider things like, if you can save 30 seconds doing this, and there might be 4 problems relating to GCF or LCM, not necessarily directly, but indirectly, because it might be a multi-level word problem where one part of it involves that, you just saved 2 minutes. That's enough to do another question. That's 2 minutes, which is enough time for you to go to the bathroom. The list goes on, all right? So what we're going to do is, with the GCF, first of all, I'm gonna say this. I'm going to just talk about it. It's probably not even worth writing down because my handwriting is so bad. I'm just going to say it, and then we're going to do a whole bunch of examples. So the first thing we're going to do is take the 2 numbers, and this will work with more than 1 number, but we're going to start with 2. Take the 2 numbers and find the least positive difference between the numbers. So this means if we have 1 and 99, the difference is 98. So we're going to take 98, okay? And we're going to see if any of the other numbers have that as a factor, okay? If they do, then you're done. You figured out the GCF. Just like that, bang, bang, you're done. There's nothing else to write or do. And so on some of these, you can actually do this in your head. That's how fast it is. So some of these, even though I just said I'm not going to promise you're going to do it in 3 seconds, some of these can be done literally in seconds. Okay? And this sounds like I'm going counter to some other stuff I say, because I keep saying write everything down. But this is one of those things, you're not going to write down 1 plus 1 all the time. You might write it down for procedure to just follow where you're going. But you're not going to write on the side 1 plus 1 equals 2, even though on the side you might do like 2, 3 times 4, 5. That you're going to write out, because that's kind of a side thing, and most people can't multiply 2, 3 times 4, 5 in their head. Things like that. And by the way, even multiplication is something I think I'm going to eventually head to with you guys, because a lot of you guys are taking too long to do it. and you're doing it erroneously on top of it. All right, so it's an error-prone, tedious kind of process, and so is this. So if we can jump away from all this, the crap that you have to go through to figure out LCM and GCF, why not, right? So anyway, we're going to get the difference. If the thing is a divisor, you're done. If it's not a divisor, you're going to see what's left, and you're going to see it in the examples what I'm talking about. Once you see what's left, we're going to get the factors of what's left. And I'm going to get what I'm going to call top-level factors. So for instance, if I have 12, the top-level factor is not 2, 2, 2, 2. It's 6 times 2. In other words, what's the largest number that can be a factor, and the other side of that factor pair. So we're trying to look for the largest number, okay? And then once we get that, we're going to repeat the same cycle and see if anything's a factor of that. And if it is, we're done, okay? And if we get to the point where we only have something that ends up with a 1, then that means there's no greatest common factor, and that it's normally 1, as it always was, okay? So let's go through some examples, because this is probably just a lot of mumbo-jumbo, basically. So if I have GCF of, I should have done this bigger, 18 and 24, okay? So what we want to do is subtract the 2 of these. So the difference is 6, okay? So does 6 go into 18 and 24 evenly? The answer is yes. So boom, you're done. 6 is the answer. That's it. There's no prime factorization trees. There's no factor pairs. There's no other thing. You just solved that instantaneously. You subtracted the 2 of these, and you saw if that answer divided into here and here. And everybody can do that in their head. So bang, you're done. I'm going to run through all the scenarios of the English description I just gave, of 50, 100. So again, we subtract the 2 of these, you get 50. Does 50 go into here? Yes. Does 50 go into here? Bang, you're done. It's 50. That's it. The greatest common factor is 50. 50 is a factor of here, and 50 is a factor there. Bang, you're done. Okay. 4 GCF of 4 and 18. Okay. Subtract the 2 of these. We subtract them and we get 14. Okay. 14 doesn't evenly divide into 4, and it doesn't evenly divide into here too. So what we're going to do is now take this subtraction answer, and we're going to split it into its greatest factors, its top level. In this case, that's the only 2 minus 1 in itself, which is going to be 2 and 7. So we're going to take the larger number there, okay, and see, does that divide into here? No. Does that divide into 18? No. So now let's try the smaller one. Does 2 go into 4? Yes. Does 2 go into 18? Boom, we're done. That's it. We're done. 2 is the GCF. Okay? We have GCF. So I'm just going to bang through a lot of these. So this might be a video to replay a lot, just as you go through these yourself and learn the rules through osmosis, really, because I can pop up the formal description, but it doesn't mean anything until you start going through the examples. So the difference between these two is 27. Can 27 go into 24? No. Can 27 go into 51? No, because twice would be 54. So, so what we're going to do is get the 2 top-level factors of this, 9 and 3. Okay? Does 9 go into 24? No. Does 9 go into 51? No. So we're not going to do that. Does 3 go into 24? Yep. Does 3 go into 51? You guys better know at this point that it does. Right? That's 17. So boom, it's 3. That's it. We're done. It's 3. Okay? So GCF of 8 and 14. The difference is 6. 6 goes into 8? No. 6 goes into 14? No. Factors are 3 and 2. 3 goes into 8? No. 3 into 14? No. 2 into 8? Yes. 2 into 14? Yes. Boom, you're done. Just like that, guys. Just like that. Let's see, that's page 11. So here comes one which becomes more of a special case. GCF of 3, 4. So the difference of them is 1. All right? So that's it. You're done. Once you see the 1, that's it. GCF is 1. because it means there's no other thing. The factor of 3 is 1 and 3, and the factor of 4 is 1 and 4. So if you get a 1 here, bang, you're done. Boom. Okay? So that was one of the rules. So let me get another piece. Okay, we'll use the other side of this. So we have 12 GCF of 12, 36. The difference between those is 24. 24 goes into here? No. 24 goes into here? No. Okay? So we're going to get to two top-level things, 12 and 2. 12 goes into there? Yep. 12 goes into yet. Boom. You're done. That's it. Okay? GCF of 18 and 12. The difference is 6. Okay? 6 goes into 18? Yes. 6 goes into 12? Boom. You're done. Okay? 54 and 35. GCF. Okay? The difference is 19. Okay, 19, does it go into there? Does it go into there? So we have 3 ugly numbers now at this point. 3 ugly numbers. So it turns out it's not divisible. Okay? And the factors of 19 are 19 and 1. Well, we already tried 19, so the only thing left is 1. Boom, we're done. Do you see how that worked? The difference was 19. 19 doesn't go into them. So we factor the remaining number. Okay? It's 19. We already tried it, and the only other one is 1. So boom, we're done. Okay, so now we're going to go into when there's more than 2 numbers. So there's in this case, there's going to be multiple subtractions. So we're going to subtract this and get 3. Okay. We're going to subtract this and get 6. Okay. And we're going to subtract this and get 3. All right? So we're going to, out of those 3, so we get 3, 3, and 6. We're going to take the smallest one. So there's 2 3s, so we're going to take 3. Okay? And now that we have 3, we're going to run through the same process. Does 3 go into 3? Yep. Does 3 go into 6? Yep. Does 3 go into 9? Yes. Boom, we're done. Right? So granted, 3, 6, and 9 are easy in numbers. Some of you can get the GCF in your head of doing this, which again is what we're trying to accomplish here is the no hesitation math. All right? Let's see, where's my next example? I'm going to take the GCF of 0, 5. Okay, so we have a 0. So the difference is 5. Does 5 go into 5? Yep. Does 5 go into 0? Yes, it does. 0 times with no remainder. Boom, you're done. Okay? There's no confusion here. In fact, this is even more clear than doing it the other ways, where even though the list of rules here are harder, once you get to just flow with them, it just flows, baby. It definitely flows. That definitely deserves a like on this video. Okay? And if I have the GCF of -2, -4, first of all, we already explained that this is the same as the positive ones, but let's get the difference here. It's 2. Does 2 go into -2? Yes, it does. Does 2 go into -4? Boom, we're done. Okay? So if I have, let's try another one, GCF. And I'm just doing so many examples so that if you're not quite catching this, and again, you can replay this 1,000 times until you understand this whole process. So we have 3 and -6. Okay, the difference here is 9. Does 9 go into here? Nope. Does 9 go into here evenly? No. So this becomes 3 and 3. Does 3 go into 6? Yep. Does 3 go into -6? Boom, we're done. It's 3. Okay, so if I have GCF of 5, -5, and by the way, we know that when the number is the same, that the answer is that. We know any negatives, we can just flip the positives. And the greatest common factor of a number in itself is itself. But let's just go through the rule. So the difference here is 10. 10 goes into 5? No. 10 goes into -5? No. Factors, 5 and 2. The highest one is 5. 5 goes into 5? Yep. 5 goes into -5. Boom, you're done. Okay? And we can even do it with GCF of 5, 5. The difference here, 0. Okay? So once you see a difference of 0, boom, you're done. It's the number itself. Okay? So I believe that's the end of my my GCF examples. Let me see here. What do I have here? All right, so this is kind of gloriously obvious. Again, once you go through the examples, the rules should be kind of self-explanatory at this point. And what you need to do is sit down with all these examples, run through the video one more time to see if you follow it, and then write all the examples down. As you run through the video, don't try to solve them. Just conglomerate all the examples together. Watch the video one more time if you're not watching it live. Write down all the examples, and then try to figure them out yourself. And what you might find is the first one you might screw up totally. The second one you might kind of half screw up. The third one you may or may not get right. And by the time you get to the fourth one, boom, you're done. Okay? All right, so let's see, how far are we gone so far? 20 minutes. We're not at 4:30 yet. So now we're going to try to do LCM. Okay? And it's kind of going to have the same thing. So what we're going to do is when we have two numbers, x and y, we're going to try to find the largest number. Okay? And then we're going to see if the other number is a factor of the larger number. If it is, boom, we're done. Okay? If it's not, we're going to take a multiple of this and then see if it can be dividing too. All right? And there's also a little twist when it's a prime number. So why don't we just go through the examples again, and boom, we'll be done. So if I have LCM of 5, 10, take the largest number, right? And we ask, is 5 a factor of 10? Yes, it is. So then boom, we're done. That's it. That's the larger number. Okay? If I have LCM of 3, 4, the larger number is 4. So is 3 a factor of 4? No. So what we're going to do is get the next multiple of 4, which is 8. Okay? Is 3 a factor of 8? No. So what we're going to do is get the next multiple of 4, which is 12. Is 3 a factor of 12? Yes. Boom, we're done. Again, no prime factorization trees, no nothing. We're just following this. Okay? Okay. LCM of 8, 14. The larger number is 14. Is 8 a factor of 14? No. So what we're going to do is get the next multiple of 14 is 28. Is 8 a factor of 28? No, it's not. So what we're going to do is get the next factor of 14, which is 42. Be careful. 14 times 3 is 30 plus 12 is 42. Is 8 a factor of 42? You better know your multiplication table. No, it's not. So we need to go to the next multiple of 14, which is 56. Is 8 a factor of 56? By the way, I say is it a factor? It goes both ways. 56 is a multiple of 8, and 8 is a factor of 56. So we can get both of those true because they mean the same thing. Okay? Then it turns out that 56 works. Because we're already getting multiples of 14, and if 8 can go into here, that's also a multiple of 8. And that's true of all the other examples we did now. So boom, it's 56. So this one we had to try a few. Okay? So, and some you're going to have to try a bunch, and then some you're not. We're going to get to one soon where I'm going to say something about this whole process. So 18 is the larger number, but 4 and 18. Is 4 a factor of 18? No. So what we're going to do is get the next multiple of 18, 36. Is 4 a factor? Yep, boom, we're done. Okay? 8 LCM of 18 and 24. The larger one is 24. And by the way, I'm writing them in order. This could also be 24 and 18. It doesn't matter what order you put these in. So is 18 a factor of 24? No. So get the next multiple is 48. Is 18 a factor of 48? No. Get the next multiple of 24, which is 72. Is 18 a factor of 72? Yeah. Again, you guys need to know this stuff. So don't just say, oh, that's an ugly number, that's an ugly number. No, it's not the case. It is. It's times 4. So boom, you're done. It's 72. All right? So now let's do the LCM of 24 and 51. So 51 is the larger number. Okay, is 24 a factor of 51? No, it's not. So when you get the next multiple, which is 102, is 24 a factor of 102? That kind of gets uglier. It turns out it's not. So when you get the next multiple of 51, which is 153, is 24 a factor of 153? We have to work at this one. It turns out it's not again. The next multiple of 51 is 204. Is 24 a multiple of 204? Those two numbers look like the same. They look like they're a factor of 10. But it's 24 and not 240, but 204. So you have to double check times 9, times 8, yada yada. It turns out it's still not there. So 204. So the next multiple is 255. And we keep going through this process. That doesn't work. So now we're going 305. So in this example, it's fair to say to me, wait a second, Greg, this is getting too complicated. We're multiplying this ugly number. We're starting to get super large numbers. And this technique doesn't seem like it works. So if we went through this whole thing, it turns out we would have to do it. We'd have to go through a whole bunch of examples here. And eventually, if we did a few more, we would get the 408 if we kept adding, doing multiples of 51. And basically, we were adding 51 each time. We'd eventually get the 408. And 408 is a multiple of 24. And then you would say, yeah, we got it. So this is one, though, because there's 1, 2, 3, 4, 5, 6, 7. There's something like nine multiplications you have to do here. And then you have to divide it by 24. And this definitely is ugly. So this might be a case where this rule, this fast way, it's not faster anymore. And it's probably starting to get more error-prone than the error-prone of the original way to do it. So this is the kind of thing you have to be careful about. So you have to know when you have multiple techniques, when to abandon a technique. Okay? When this hit 204, I probably would have abandoned it and gone to use one of the other ones. Probably the little box thing where you get the both of them at the same time. Okay? Because 51's a nasty number, right? And so this is not perfect. This is not perfection. So if you're finding, wait a second, Greg told me this was fast. Well, it's not fast in every single scenario. Okay? So keep that in mind when you're doing some of this. That the goal of this was to get you through a test faster, but also in real-world stuff too. But as with anything, sometimes technology doesn't really help us. How many times you're doing something and your computer crashed? Well, was that fast and I was writing a handwritten note to somebody where your computer keeps crashing? You're like, damn it, I'm going to get this done. So you need to try to resolve things like that. All right. So we have. Let's see. What's the next one I have? So there's lots of boom. You're done here. So when you get to the point like this, that last example, definitely boom. You're done. Try another way, or you're just finding that the numbers are just too hard or too complicated for you for some reason. Then it's not worth it. So we have the LCM of 12 and 36. Okay, circle the larger number. 36 is the larger number. Is 12 the factor? Boom, you're done. That's it. It's 36. If I have LCM of 18 and 12, and I think we may have done this already, but I'm not sure. 18 is the larger number. Is 12 a factor? No. So what we're going to do is get a multiple. Is 36. Is that a factor? Boom, we're done. Okay. If I have LCM of 10 and 12, 12 is the larger number. So is 10 a factor? No. So what we're going to do is keep getting multiples, and it should leap at you at some point. We're going to get 60, and then boom, we're done. So you should be able to know 10 and 12 even without using any of these techniques. That eventually multiples of 12 is going to get to the 60. So if you're looking at 10, it's going to be 6 times. You should be able to do that in your head without doing any other technique. Then this is just leap at you mathematically that it would be 60. Anyway, if you follow through with 24, 36, 48, you get 60 eventually, where 10 actually divides evenly into there. So you get 60. If we have LCM of 50 and 100, and we did GCF for this before, so that's probably why it looks bigger. The larger number is here. Is 50 a factor? Boom, we're done. Okay, because on the GCF 50 was the answer. If I have LCM of 54, 35, I'm going to leave this as an exercise to you guys. But what's going to happen is you're going to eventually 54 is the larger number. That's not a multiple, and you're going to get 108, 162, 216, 270, and then it gets uglier. And it turns out, I believe you have to do this 35 times, because the actual LCM, it turns out to be 54 times 35, which in this case is equal to 1890. Okay? So this is another one where where this kind of fast technique, it doesn't work. The numbers are just too ugly, and there's too many big numbers here that you have to divide by 35 to see if it actually works. So in this case, this is another one where the technique just doesn't work, okay? If I have the LCM of 0,99, remember, you can't do the LCM of 0. It's undefined. So the whole thing, there's no answer. It's undefined. So remember that. So if I have the LCM now of 3 numbers, 3, 6, and 9, okay, it's going to work the same way. 9 is the largest number with those, okay? Okay. 3 is a factor of 9, but 6 isn't. So what we're going to do in the case of this, we're going to find the one that was a factor, and we're going to remove it from the problem. So it's as if, so this is a new rule, guys. It's as if we're going to rechange the problem to 6, 9 now. Because 3 was a factor of 9, we know 3 is cool, so any answer we get that's a multiple of 9, 3 has to be a multiple as well. So now that we have 9 and 3 is a factor of 9, we have to find out what's the factor of the both of these that match. Or the multiple, sorry. The multiple of 6 and 9 is that match. Whatever that number happens to be, 3 will match it as well because 3 was a factor of 9 already. Okay? So now in that case, we pick the larger number. So that's not true. We get the next multiple is 18. And now it is a factor. And boom, we're done. So we took 3 numbers. That could have been complicated. And it gets that way. So we have 3, 7, and 9. Again, we're doing LCM. We take the larger number. Okay? We're going to do the same process. 3 is a factor, so we're going to get rid of it. So we're going to rewrite this as if it was LCM of 7, 9. Okay? And there's a shortcut here, which is that if you find, it wasn't the case in the previous example, but if you find the other number is a prime number, then you just multiply. And you get 63. So this is another special rule. All right? If there's a factor in multiple numbers, you cross it out and you rewrite the problem. If there's the same thing here, but if you're left with only a number and a prime number, then you just multiply the 2, and then boom, you're done. All right? And boom, we're done. That's it. That's it. So I don't know how many problems we just went through, but there was a hell of a lot of them, and we did it pretty easy peasy. Now, this all said, remember there's a couple of special rules for each LCM and GCF, and also remember there's a couple of cases where the numbers get nasty enough that this technique doesn't work. Okay? There's also, I didn't give you large numbers. I didn't give you like LCM of 1, 2, 3, 4, 5, 6. Okay? And normally they're not going to be on the test that I'm trying to attend this YouTube for. So you're all good for the most part. It might be rare that a middle schooler is going to have a thing like this to do the LCM on, unless it's like an extra credit problem or something. Because you can use this beyond specialized tests. This is a valid mathematical technique to be used anywhere. Whether you're trying to figure out the size of your porch or how much pieces of lumber you have to do your porch or whatever the heck it happens to be. This would all make sense. You're trying to do a piece of artwork and you cut up a whole bunch of pieces of paper and you're trying to figure it. All this stuff applies everywhere. All right, guys? So that's the 2 techniques. They're not the end of the world, but for a lot of the examples you guys can use, basically all middle school and the beginning of high school for sure, and certainly for most tests like the SHSAT, the PSAT, the ISEE, the SSAT, the Hunter test, things like that. This will all apply to that. By the way, Hunter College was another example for the earlier thing. So there we go, people. And I did that in 34 minutes. So we just covered easily 30 problems, so we did them all in less than a minute. In fact, I'll try to count. That'll be the last thing I do. There's 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, We just did 31 problems, I believe, in less than a minute, plus with my original banter in the beginning and the banter I put in the middle and the banter I put at the end. So with that, please like this video, please subscribe, share it, pass it around, and everybody have a great day. I am exhausted, so I'm going to peace out and chill out, and probably come up with more examples for you guys for tomorrow. I'm tutoring kids in the middle of this. I'm actually going to relax for an hour and a half or something because I have a kid to tutor later. And then I'm tutoring some kids in the morning. And I'll probably do another Ask Me Anything at some point. And yeah, let's get all this going, people. Chill out, baby.